Hello, this is Mr. Henry, and welcome to Lesson 6.2. We're continuing our discussion on scatter plots. Now we're going to be looking at more of interpreting them, still interpreting them. We did some of that last lesson, doing a little bit more with line of best fit, and going from there. So the essential question says, how do I interpret scatter plots? And the warm-up says, scatter plots are used a lot outside of school. How do you think scatter plots are used outside of school? So put your opinions down, put your thoughts down in your warm-up space. Go ahead and pause the video. When you're ready to continue, hit play. We'll go through it together. Alright, so scatter plots are used a lot, especially in science. Anytime somebody's trying to find if there is a relationship between two variables. Global warming is a big thing that people are talking about right now. So they're looking at different variables and trying to see if there's a relationship. So if they're looking at and if they gather some data on the amount of carbon in the atmosphere, different types of carbon like CO2 and carbon monoxide, carbon dioxide that are being released by cars, and the temperature of the oceans or the level of ice caps. We'll say temperature of oceans. Well, if they take all this data and they look at during this specific year how many hydrocarbons were in the atmosphere and what was the water temperature, and then this year and then this year and this year from all around the world. They don't just do one specific place, they do all around the world. And if they plot that data, they're going to find, now there's going to be lots of variance in it, but generally speaking, the consensus seems to be, scientific consensus seems to be, that there is a relationship between the more carbon monoxide or carbons in the atmosphere, the higher the temperature of the oceans. And that would lead to global warming, because the warmer the oceans, it melts the polar ice caps, and that causes a big snowball effect. But something like that is the relationship between the amount of carbon in the atmosphere and the water temperature of the water. Is the relationship between the amount of sugars we eat and diabetes. Well, somebody did a survey, did a study, and studied some people over a period of time and recorded how many sugars people eat and if they got diabetes, and they found that there's a connection between those two. And so this is used a lot anytime somebody's trying to study if two variables have a relationship with each other. Okay? So we have two vocabulary words. Now, the first one, actually both of these are old from the last lesson, so it's the same exact thing. Scatterplot is a way of displaying bivariate data when both variables are numerical. And the line of best fit is a line that attempts to model the data represented in a scatterplot. And the line of best fit is linear, line, straight. So we won't be talking about so much of the non-linear in this lesson. We'll be looking at just linear. Okay? So let's go ahead and get right into it. So it says the graph below shows a scatterplot of a research study at a middle school comparing hours of sleep each night and the students' achievement. So the amount of time they sleep and how much they're achieving. Okay, so I guess that's determined by their grades. Draw a line of best fit for the data and write the equation of the line of best fit. Okay, so we're going to take this data and we're going to attempt to draw a line. So I'm going to use my line tool. You can use a ruler or a straight edge or a folder or another piece of paper, something. So I'm going to change color a little bit just so it stands out. We'll go blue. So let's go. So usually what I do is I draw a line. Since I can do it on the computer, I draw a line and I end up changing it a little bit. So my line, there's my first attempt. Now I don't like it. I think the slope, it's a little bit too like this. I think it needs to be more up and down. And then maybe down here a little bit. How's that look? Does that appear to be in the middle of the data? Maybe I adjust slightly. This would be something you'd do with your ruler. That way, because you don't want to draw a line over and over and over and over again. So that looks pretty close. Maybe I bump it up a little bit or down a little bit or something just just tweaking it a little bit, but I think that's pretty close to the data. Okay, so we drew the line of best fit. The second part of this was to write the equation. Now, we did a little bit of this a while back in Module 4, sometime in the middle. We were talking about writing equations of lines. And we did a lesson where we were writing equations of lines from a line. If they gave us a line, we had to write the equation. Well, now that I have a blue line here, we can write the equation of this. So we need to talk about a couple things. To write the equation of a line, we'd like to talk about what is the slope of the line and what is the y-intercept of the line. So let's see. So looking at this line, the y-intercept appears to be, since that's the easiest one, I'm going to go with 0. I'm going to go 0, that if a person gets 0 hours of sleep on average, consistently, they're going to get 0 achievement. They're probably going to get a 0 in school because they're going to be dead. You can't live with 0 hours of sleep. But according to the data, it looks like the y-intercept is 0. So I'm going to go with that. Now, slope. So what I'm doing is I'm looking at my blue line, and I'm trying to find places like this, where the line is going right through one of these crisscrosses. And it actually looks like the way I drew my line, it's going right up this diagonal. That's pretty sweet. That actually makes it easy for me. So what is the slope? Well, we can do the counting box method. So I would be wrong to say you're going up 2 over 2 and just saying your slope is 2 over 2, because this is not up 2. From here to here is up 20. You're going from 0 to 20. So it's up 20 over 2, from 0 to 2. Up 20 over 2 simplifies to 10. So I would call the equation of this line y equals, we'll use mx plus b form, where m is your slope, b is the intercept. That would be the equation of my line. Y equals 10x plus 0, where x is the hours you slept, and the y variable is your score, or your achievement. I don't know how they're measuring achievement, maybe grade. Okay, sweet. So draw a line of best fit, write the equation of the line, check. Let's see what they have us do now. It says, on average, how many hours of sleep would a person need to get each night if they wanted to get a 90%? So let's go back here. It's the same data, but this one has our line and our other stuff on it. So if a person wanted to get a 90% here, well, according to our line, and I bet it's going to be according to our equation as well, they would need to get, on average, 9 hours of sleep. 90%, our line crosses at 9 hours. And if we try to use this using our model, using our equation, check this out. If they wanted a 90%, if they wanted a grade of 90, grade was their y variable, divide by 10, divide by 10, we'd find an x value of 9. They would need 9 hours of sleep to get a score of 90. So 9 hours of sleep. Now, this data is not entirely realistic, but you get the idea. It's, using the data to answer questions. That's what we mean by interpreting the scatter plot. I think there's another question off the same data here. What does the slope of the line mean in terms of the given scenario? So let's go back to the equation. What does the slope mean, this 10, in terms of the scenario? What does that mean? Well, slope is a unit rate. Slope is the change in y over the change in x. And so we found a unit rate of 10 over 1. So if I throw the labels in here, my y variable is my grade, and my x variable is my sleep. What this tells us because I have a slope of 10 over 1, that means if I want my grade to increase by 10 points, I need to get 1 more hour of sleep, because it's positive, they're both going up. So for every 1 hour of sleep you increase, your grade increases by 10 points. So look at it. When you get 1 hour of sleep, 10. 2 hours of sleep, 20. 3, 30. 4, 40. 5, 50. 6, 60. 7, 70. So for every 1 hour of sleep you get, additional hour of sleep you get, your grade increases by 10%. According to this data. I'm not saying this is realistic, but according to this data, that's what it means. So what does the slope mean in terms of a given scenario? For each additional hour of sleep, your score, your grade, we'll call it grade, increases by 10%. So because we had a slope of 10, every unit you go over sideways, your score increases by 10. So every 1 hour of sleep, 10%. 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 That's what it means. Letter B. Now I know this data is probably it might be pretty small on the screen. I'm sorry, it's also on your paper if you download the PDF from above the video on this website. If you don't have the PDF, you don't have the website, it's shawnhenry.org, SHAWN, henry.org, not .com. So it says here, the table below shows the years of education and income of people based on data collected by the IRS. So based on information collected by the IRS, this shows how much education a person has and how much money they're making. That's their income. So we have in our table down here, where's my cursor? There it is. So our education will be our X variable. Our monthly income, the amount of money you make per month, will be the Y variable. So we want to draw a line of best fit and asks us what type of correlation is present. Well, in order for us to do all that stuff, we have to start by making our scatter plot. So I'm going to make a scatter plot. So we've got what? Education. And we've got income. All right. And my years of education go from 8 is the lowest, 16 is the highest. I don't think I want to go 2, 4, 6, 8, 10, 12, 14, 16, because all my data would be between there and there. That's a lot of wasted space. So what about if we do this break in the scale thing? So 8, 9, 10, 11, 12, 13, 14, 15, 16. Ooh, I like that. So 8, 9, 10, 11, 12. I shouldn't be labeling every one because it looks going to look ugly. 13, 14, 15, 16, 17. All right, and my income. My amount of money people make, what is the lowest? I see a 17. Ooh, there's a 14. Anything less than 14? Nope. So it would be ridiculous for me to go like count by thousands. 0, 1,000, 2,000, 3,000, 4,000. I think the highest is, I see a 4,100 here. So just over 4,000. So that would be pretty dumb to count by thousands because my entire data would be from like here to here. I'm not going to count by ones or fives or tens or hundreds. So I think I got to do this break of the scale thing again. So break, break, break. And let's see. So I've got to go from about, we'll say 1,000 down here. And I've got to go to about, we'll say 4,500 if I'm counting by 500s. Does that work? 1,000, 1,100, 2,000. I'm still trying. I don't even know if this is going to work. So don't copy just yet. 2,000. Whoa, it's 20,000. I can't zero today. 2,500, 3,000, yeah, this will work, 3,500, 4,000, 4,500, 5,000. So yeah, this scale will work nice and pretty. So my bottom axis, I have a scale of counting by ones, but I have a break in the scale from 0 to 8. So I'm ignoring all the stuff from 0 to 8, and here I'm ignoring all the stuff from 0 to 1,000. Actually, I probably could have counted just by 0, 500, 1,000, 1,500, 2,000, 25, 3,000, 35, 4,000, 45, whatever. So here we go. Let's go ahead and do some plotting. So person who has 8, no, over here. Start from the beginning, not in the middle. So a person who has 11 years gets $2,000 a month. 10 years gets $1,700 a month. 13 years gets $3,200 a month. 14 years gets $2,800 a month. 8 years gets $1,400 a month. 11 gets $2,200. 16 gets $3,900. Ooh, aren't they richy rich? So that far. 9 gets $1,500. 10, $1,900. That's about the same place. 15 over here gets $3,600. Where's 36? There's 35. So 36 right above. All right, top row done. Next row down. 14 years gives you $3,600. 12 years gives you $2,800. 15 years gives you $3,500 right on the dot. So this far. 12 gives you 22. 12 gives you 22. 13 gives you 29. 14 gives you $3,100. 16 gives you 4,000. So that far. 10 gives you 1,600. Where's 16? There's 15, 16 to be here. 12 gives you 2,400. 12 gives you 2,500, and 16 gives you 4,100. Where's 41? 41, right about there. All right. So I have all the piece of data now. So we constructed our scatter plot. Now we want to draw the line of best fit. All right. So I'm going to use my line tool, and it looks like my line should go almost perfectly right down here. I mean, I'm going to lightly, so maybe on your paper you lightly do this. Draw a burrito in here. All right. So I have a little light burrito in here. And so my line of best fit would go right through the middle of that. And so it'd be something like, no, I didn't want that. Oh, my line tool. About like that? Does that seem about right? Yeah, I think that looks pretty good. It's a little high on this end, maybe down just a teensy bit. There we go. I think that looks like a pretty good line of best fit. Now, they're not, I mean, everybody's going to have a slightly different line. Don't think because your line is different than mine that it's wrong. I mean, if you had yours where I had mine a second ago with this, like up here a teensy bit, it's not wrong. I mean, if you're trying to do this using a computer can give you an exact answer. We are going to be estimating a line of best fit. The idea should be that if I gave you a couple lines, a couple red ones here, you should know that that's not right, and that's not right, and that's not right. You should, I mean, out of those 4 choices, the 3 red ones and the blue one, you should be able to pick out that the blue one is the correct line of best fit because it's the one that models the data that is in the middle of the data. Okay. Draw a line of best fit. Check. What type of correlation is present? So it's asking us to describe the correlation. So this is positive. It is, I would call that strong. And is it linear or nonlinear? Well, this is definitely linear. So this is a positive, strong, linear correlation. That is describing the data that is present. All right. So I have my graph here that I plotted. And so you see my scale that I used on my answer keys, slightly different than what I used on my other page. It's not going to make a huge difference, but it's just slightly different. So based on the model, which is the line that you drew, so this is the one I came up with earlier, this is the one I came up with you. So based off the line you drew, what is the income a person who went to college for 2 years would expect to make per month? So a person who went to college for 2 years would be, well, 12 years as you graduate high school. So 2 more years would be at 14 years of education. So how much would that person at 14 years expect to make per month? So based off our model, let's see. This model, ooh, that wasn't a very good line. This model here is roughly, I don't know, 28, that looks like 32, approximately, I don't know, 3,300 a month. Here's an example. I did the same problem earlier when I made up this part of the lesson. This is the scatter plot and the scale I used, and this is the scatter plot and scale I used the second time. You notice how it's not the same? That's just showing you that you don't have a one specific correct answer. That I did this problem 2 different times. I got 2 very different scales and scatter plots, but my answer should hopefully be the same. So like, it's asking about 14 years of education. Let's see. 14 years of education. I have, look at that, just over $3,000. So I don't know, what did I say before? 3,300? That seems reasonable. According to this line, it's between 3,000 and 3,500. So, I mean, both of my lines, both of my scatter plots and my lines of best fit gave me around the same answer. That's kind of what we're looking for. So how much would this person expect to make per month? I'd say $3,300 per month. That's based off the line we drew, which is our line of best fit. You wouldn't be able to use just the data so much without the line. If I move this line out of the way, no, I can't. But you wouldn't want to move that line out of the way if you didn't have a line here and based off the data, because the data is so varied, it's hard to find a good middle place. So when you have your line in there, your line helps you make these predictions. So based off our model, we can say where we think that 14 years, $3,300 would be. Okay, same information, same data. How much more a year would a college graduate, which is 16 years of education, make than an 8th grade dropout? Okay, so based off our model, this shows how much a person makes per month. So we want to know in a year, how much would a college graduate at 16 years make more than a high school dropout, or an 8th grade dropout, I should say. So up here at 16, this person is appearing to make, I don't know, that would be $4,000 per month. So a college grad is making $4,000 a month. An 8th grade dropout is making $1,200 a month. So what is that difference in terms of a year? Well, there's 12 months in a year. So this guy's making $4,000 a month times by 12 months would give him $4,800, or I'm sorry, $48,000 a year. This guy times by 12 gives him 14400. So a college graduate could expect to make $50,000 a year, where an 8th grade dropout would make $14,000 a year roughly. So how much more? You subtract. 0, 0. There. So I don't dirty this up and get lines going everywhere. 4,800. So clear. 48,000 minus 14,400 equals 33,600. So a person who graduates college with 16 years could expect to make $33,000 more a year than someone who drops out at 8th grade. And you can make these predictions from every grade. I mean, even someone who graduates high school. If you just graduate high school and don't go to college, you could say, high school graduates making, we'll say $2,500 a month. And person who's graduating college from 4 years is making $4,000 a month. That's still going to be a significant more amount of money a year, which is why we're telling you folks, get your education. Letter C. The table below shows the collection of data measuring the thickness of polar ice caps from the past 25 years. Construct a scatter plot for these data and sketch a line of best fit. Write the equation of the line of best fit. So go ahead and pause the video. Do it right now. When you're ready to continue, hit play, and we'll go through it together. All right, so here we have some graph space and we have some data. So our x variable is the years since 1980. So they're measuring every year since 1980. And the y variable is the amount of ice gain or lost. Did the amount of ice go up or down in that time? Now looking at it, since all of these data are negative, what I'm going to do is I'm going to make my x and y axis a little bit different. I'm going to have my x and y axis like this. So this would be 0 on the x, and this is 0 on the y. So my top axis is years since 1980. And I'm going to go from what? 0 to 25, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Oh, that is perfect. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Nice. My y-axis is going from 0 to 10, negative 10 I should say. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll take it. Negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So I need my axis to look like this because our scale is all going down. So now, if you had trouble before, maybe copy the scale I have in, and now try to plot your data. Try to do it on your own. If you can't, well then just continue watching and we'll go through it together. So 0, 0. I'm going to change colors here to make it stand out. And 25 years, negative 10. Will be right there. 6 years, negative 1.8. 6 years, negative 1.8. 8 years, negative 2. Whoa, I hate it when it does that. 8 years, negative 2.5. 3 years, negative 0.4. So there's 3, 0.4. 4. 17 years, -5. 17 would be here, -5, I said, right? 20 years, -5.9. 20 years, -5.9. 15 years, -3.2. 15 is here, -3.2. Whoa. And I think I got one more, right? Yeah, 23 years, -8. 23, -8. All right. So we have this collection of data, and this is kind of like the example I talked about way back in the introduction about determining if there's a relationship between two different variables. So is there a relationship between the amount of years since 1980 and the amount of ice gain or loss? Well, looking at the data, I would say yeah. So each year, the amount of ice gain or loss, it appears that it's consistently losing ice each year. But we might be asked about that later. So let's keep going here. So construct a scatter plot and sketch the line of best fit. All right, let's sketch this guy in here. So my line of best fit is kind of linear-ish. I don't know, something like, I didn't mean black or red line. I actually tried to do a black line. There we go. I mean, what do you think about that line? Maybe up a little bit? Like that? I mean, do I have roughly the same number of lines of points above and below the line? I've got 1, 2, 3, 4, 1, 2, 3, 4, 1. Yeah, I mean, that's roughly about right. It's close. Doesn't have to be exact. So sketch, done. And the second part was, or the third part, I guess, was to write an equation. So to talk about the equation, we need our slope, and we need our y-intercept. So the y-intercept of this line, if we continue it till it hits the y-axis, it appears to be crossing at -1. The slope of this line, let's see, try to find some, that's an intersection point. There's one, but I don't like to picture they're too close together. I mean, but it does appear to be, I mean, roughly down 1 over 1, down over, down over, down over, down over. I mean, it's not exactly that, but it's close. I mean, I could pick up some, I mean, that would be a slope of down 1 over 1. That's pretty close. I'm going to go ahead and say that. I'm going to say down 1 over 1. Now, be careful of your scale. Is this actually down 1 and over 1? Let's see. This is down 1, yes. So from there to there is down 1. Down 1. And this is over 2, because that's 2 years. So the scale is actually, the slope is down 1 over 2. We have a slope of -1/2. So our equation would be y equals -1/2 x minus 1, where -1/2 is the slope and -1 is the y-intercept. All right, so we have that same information, so you're going to use that data we just plotted and you graphed and all that kind of stuff. This stuff here. We're going to answer some questions. So based on the model you made, which is your line of best fit, and your equation, what is the amount of ice gain or loss in 1990? So answer that question for yourself first. Let me see if I can erase some of my extra junk in here. What is the amount of ice gain or loss in 1990 based off our model? Okay, so based off the model, 1990, so how many years since 1980 is that? That would be 10 years. So when this is equal to 10, this would be the year 1990. There appears to be that much, which is -3. So the amount of ice gain or loss is -3. Is that feet, meters? Meters is our unit. So based off the line, we found it was -3 meters of ice have been lost since 1980. Based on the model, predict the amount of ice gain or loss in the year 2015. So 2015, how many years since 1980 is that? Let's see. 2015, calculator this thing. 2015 minus backspace 1980 is 35 years. Okay, do I have 35 years on here? I don't. So this goes up to 24, 26. So I need to like way out here somewhere. So our graph, our data is not going to help us here because I need 35 years. Luckily, we still have our equation. The x variable is our years. So if we want to know what happens in 35 years, well, we plug 35 in for our x variable. And then our y variable is the amount of ice gain or loss. So let's do the math. -1/2 times by 35, well, that's going to be roughly 17.5. Ooh. 0.5 times by 35 equals -17.5. It's always good to check your work just in case you're unsure. And -17.5 minus 1 is -18.5. So I would predict that in the year 2015, that's the year I'm in right now, in the year 2015, there would be an ice gain or loss of, what do we say, -17.5, -18.5 meters of ice. So that would be a significant amount of ice. So -18.5 meters of ice, that's a lot of ice that's been lost in those 35 years. One more question? Yeah. What would the slope of the line of best fit represent in terms of the scenario? So our slope, whoa, what happened? Get out of here. Our slope, oh my goodness. Let me find the right page. Sorry about that. There it is. All right. The slope of the line was -1/2. What does that represent in terms of the scenario? Well, if the slope was -1/2, let's look at our labels. The top label, change in y over change in x. The top label, y-axis, with the amount of ice gain or loss. So -1 ice over 2, the bottom was years. So that seems kind of ridiculous to write it like that, but that means we lost 1 meter of ice every 2 years. That's what the slope represents. If we throw those labels back in there, so loss, let me type this out, be quicker. So loss of 1 meter of ice every 2 years. That's what that slope means in terms of the scenario. A loss of 1 meter of ice every 2 years. Letter D. The scatter plot below shows the graph of a car's age and its value. Draw a line of best fit for the data. Okay, so let's see. Line of best fit. Let's change to a nice pretty green color here. So I'm thinking it's going to be slanty down. Can we go something like that? How's that look? I think that looks pretty good. I think I got it right my first attempt. I mean, it's approximate. I'm not going to get it perfect. Line of best fit. There it is. It looks like I have the same number of lines above and below. What would be the equation for this line of best fit? So let's see. So if we're talking about equation, we need to talk about our slope and our y-intercept. So slope. That appears to be an intersection point, and there. I mean, that one's close. So let's go with those. So from that little bit of information, I would say, what? Down 1 over 2. But that's not actually right, because it's down 1 block, but that 1 block is not $1. So what is down 1 over 2 in terms of our scale, in terms of our labels? So down 1 appears to be, well, this is 2, 4, 6, 8, 10, 12, 14, 16. So it's like down $2,000. So down 2,000 over 2. Is this actually 2 years? It is. Simplify, negative $1,000. And the y-intercept appears to be, if we continue, $18,000. So my equation in slope-intercept form, y equals negative 1,000x plus 18,000. Even though it's kind of ugly, it's really not that bad. I mean, the slope wasn't hard to find, the intercept wasn't hard to find, the numbers are big, but it's really not that bad of an equation. So based on your model, which is what we had just the last page, I'm going to flip back to it here. What would be the value of a car that is 14 years old? So again, we can't predict 14 because our graph doesn't go out that far. It would be way off the screen here. So based off the model, which is our line or our equation, I can make that prediction because our x value is our years. So if I plug in 14 years in for the x, that would be a prediction of the value of a car that is 14 years old. So y equals, let's see, that would be negative 14,000. That would give us $4,000. So based off of our model, which is our equation and our line, we would predict that a car that is 14 years old, a 14-year-old car, would have a value of $4,000. This is why that line of best fit can come in very handy, because sometimes you can make a prediction that's not in the graph. We're extrapolating a little bit here. What would the slope and the y-intercept represent in terms of the given scenario? All right, is that right? Yeah. So we said the slope is negative 1,000, and we said the y-intercept is 18,000. So what do those mean in terms of the scenario? So let's see. Slope was negative 1,000, and y-intercept was 18,000. So slope, we've been talking about slope is this change in y over change in x. The change in y is negative 1,000. Change in x is 1. Well, if we throw our units back in there, that's negative $1,000 and 1 year. So that means every 1 year you go across this way, the value drops by about $1,000. Your car loses $1,000 of value each year. Okay? And so, I mean, you'd write that out in words. I don't have space here. And the y-intercept, 18,000. Well, the y-intercept would be where the line crosses when the x value is 0. So when your age of the car is 0, that would be the approximate value of a new car, a car that's 0 years old. So $18,000 is the cost of a new car. That's what it would represent in terms of this particular scenario, in terms of the data that we were given. $18,000 would be about the average price of a new car. Looks like we've got one more question here on the same data. So still based off this same data, and just so I have it here, y equals, it was negative 1,000x plus 18,000. I think that's going to come in handy again. How much money could you save if instead of buying a new car, you bought a car that was 2 years old? So a new car, we said, would be about $18,000. So if we bought a car that was 2 years old, what would that be? Well, a car that's 2 years old, let's see, y equals negative 2,000 plus 18,000, y equals 16,000. So a car that's 2 years old, which is not that old, would be $16,000 roughly. So the difference, how much money could you save? A new car is $18,000. A 2-year-old car, is $16,000. So you could save $2,000 by buying a slightly used car or slightly older car versus buying a new car, according to the data we're given. All right. And for our summary, we have a Collins type 1. So again, you write, as long as you're writing, you're correct. You've got 2 minutes, and it asks, write for 2 minutes, summarizing what you've learned about scatter plots in the past 2 lessons. So go ahead and pause the video, and in your summary box, just put down what you have learned about scatter plots in these last 2 lessons. When you're ready to continue, hit play, and we'll go through it together. All right, so I went ahead and I typed out some of the things that I hope you learned. So scatter plots can be strong or weak. They can be positive or negative. They can be linear or nonlinear. They can have no correlation, which means there's no relationship. Scatter plots show the relationship between 2 variables. They show, is there a relationship or is there not a relationship? Is the relationship positive, negative, strong, weak, linear, nonlinear? You can make a line of best fit for the data. The line is a model and can help you make predictions about the data. So these are all things I hope you learned about scatter plots in these previous 2 lessons. This has been lesson 6.2. Thank you for watching.